So 8.2b, are you ready to continue on with the simplified form and properties of radicals? This is going to take practice. You're going to have to keep practicing and practicing this stuff in order to get it. It does not come really easy, and it's a lot of stuff to remember. I get that. So anyway, let's look at the quotient property. And basically what the quotient property says is that if I have the square root of 4/9, that equals the square root of 4 over the square root of 9. We can split that radical up. And what is the square root of 4? What is the square root of 9? So that is actually the square root of 4 over 9 simplified. So let's look at example number 7. Square root of 49 over 81 equals the square root of 49. Square root of 81 equals 7 over 9, and you're done. Okay? When you have one as miserable as number 8, because we've got a stinking fourth root, that equals the fourth root of 81 over the fourth root of 16. So what number multiplied by itself 4 times gives you 81? What number multiplied by itself 4 times gives you 16? Okay, and you're done. All right, let's look at example number 9, and of course they're going to start getting harder and harder. Doesn't appear to be hard, and I think you'll find it's not really too terrible. First of all, we do this, and we just simplify the numerator, and then we simplify the denominator. Now the denominator is really easy to simplify, so let's just leave the numerator alone, and square root of 49 is 7. So now all we have to do is simplify the numerator, find two. All right, the index on this is 2, so that makes it easier. Find two numbers multiplied together to give me 50. Well, 5 times 10, 25 times 2, and I am going to pick this one because I need one that I can take the square root of. So again, if there's a radical or an index here of 2, find two numbers multiplied together that give you this 50, and where you can take the square root of one of them. If this were a cubed root, it'd be find two numbers multiplied together that give you 50, and one of those numbers you could take the cubed root of. Okay, but since it's a square root, we're going to take the 25 and 2. So we're going to write that as the square root of 25 times 2 over 7. What's the square root of 25? 5, and the 2 we can't do anything with, and we end up with that for an answer. All right, one of the things that I want to bring up is notice how I went from the square root of 50 to the square root of 25 times 2. Okay? This can also be written as the square root of 25 times the square root of 2. And that's actually how I got 5 square root of 2 if you look at this, because 25 times 2 is the square root of 50. Well, what is the square root of 25? 5, and the square root of 2 I can't do anything with, so it stays that way. Okay, so that's just another way of looking at that. All right, let's jump up to example number 10. Example number 10, we have 12x squared over 25, and we take the square root of that. So we are going to first of all write it as, okay, so let's look at the top and bottom each. So this has an index of 2, so that's good. So what two numbers multiplied together give me 12 that I can take the square root of one of the numbers. And square root of 25 is 5. All right, so if I can take the square root of one of those numbers, whenever I take the square root, it just pulls it out. Now let's look at the variable. So my index is 2, so I look and say, how many times does 2 go into 2? One time with nothing left over. So I end up with 2x square root of 3 all over 5 for an answer. All right, so number 11, or example 11, it's, 5 different examples there. So square root of 12 over 6. I'm just going to kind of run through these pretty quick. That equals the square root of 4 times 3 over 6. Square root of 4 is 2. The square root of 3 you can't do anything with. 2 over 6 is 1/3. And you really don't even need the 1 there. Okay? B says 5 square root of 18 over 15. So first thing I'm going to do is I'm going to reduce this. 5 over 15 reduces to 1/3. So now I have the square root of 18 over 3. This, two numbers multiplied together, give me 18, where I can take the square root of one of them. That, I can pull a 3 out, right? Square root of 9 is 3. So I'm left with 3 square root of 2 over 3. Cancel those, and I'm left with just the square root of 2. So if I'm going too fast, slow the video down. But I don't want to waste your time, too. But I want to make sure you understand and kind of see how things are going. All right, you cannot ever, in the whole history of the universe, add a number without a radical to a number with a radical. So what do? I focus on simplifying the radical. Two numbers multiplied together give me 8, where I can take the square root of one of them. So 6 plus square root of 4 is 2. I cannot add this in this. I can't add 6 plus 2 and get 8. This 2 is attached to the radical, and when there's a radical and there's not a radical, I cannot combine these two. Okay? So, what I end up doing is splitting this up. So we've done this before. That's 6 over 2 plus 2 square root of 2 over 2. Remember doing that? This and this can be written that way. So 6 over 2 is 3. 2 over 2 can be canceled. And you end up with that for an answer. All right, let's keep plugging away here. And like I say, I know I'm going a little quick, but you know, these videos will go on and on and on for months with all these examples. All right, let's do D. We've got 4 plus the square root of 36 over 2. And again, we can do it one of two ways. We can go 4 over 2 plus the square root of 36 over 2. And 4 over 2 is 2. Square root of 36 is 6. So we have 2 plus 3 equals 5. That's one way of doing it. All right, another way of doing it. Square root of 36 is 6. 10 over 2 equals 5. Okay. Either way works. One way is not more right than the other. As long as you are following correct algebraic principles, as long as you're following the rules, it doesn't really matter how you come about with the answer. Just some people do it different than others. One's not right, one's not wrong. It's just how you do it, as long as you follow the rules. All right, so 48, holy cow. Two numbers multiplied together give you 48 that I can take the square root of one of them. Let's see, there's 12 and 4, but remember when I used 12 and 4, I said the best numbers to use are ones that one of the numbers is prime, and here neither one of them are. So let's keep writing. 16 and 3, 24 and 2. Okay, let's stop there. There's one right there, where one of the numbers I can take the square root of, the other one is prime. So I'm going to use that one. So negative 2 plus the square root of 16 times 3 over 4. All right, square root of 16 is what? 4. Square root of 3 stays in there. Can't do anything with that. Cannot add those, remember. You know, that's just impossible to do. So what am I going to do? I'm going to split these up like this. So negative 2 over 4 plus 4 square root of 3 over 4. Okay, I can cancel those two. 2 over 4 is what? 1/2. Okay? Okay, last example. Negative 4 minus the square root of 40 over 4. Now, let's look at the square root of 40 here. What numbers? Oh, 10 times 4. That'll work because I can take the square root of 4. Okay, so negative 4 minus square root of 4 is 2. Okay, so I have that. Let's see, what can I do here? I can write it as two fractions, but I'm going to show you another trick, and you're like, oh really, Gary, you're going to show me another trick? I'm so sick of tricks, I'm so lost. But we can look at this top here and factor a negative 2 out, and we're left with that. In fact, let's not do that. Let's make it a little simpler. Let's just factor out a regular old 2. Okay, and that leaves me a negative 2 there, minus the square root of 10 over 4. Okay, all I did is I'm choosing to factor out a positive 2 instead of that negative 2. All right, so that leaves us with that. 2 over 4 is 1/2. So this changes to negative 2 minus the square root of 10 over 2. Now it doesn't look too bad, so we'll go ahead and leave that. All right, let's jump to B. Okay. And again, we're going to look at our numerator and factor something out. But before that, we're going to find the square root of 48. That's always the first thing we're going to do. Square root of 48. What is that? It just seems like I just did that. Oh, that was 16 times 3. Square root of 16 is 4. And the square root of 3, that stays because you can't factor that. Now, I could factor a 2 out of both of these. So if I took a 2 out, that leaves me a negative 3 there, and a 2 there, and that gets me over 2. Now, look what I can do. I can cancel that, and that ends up being my answer. Okay. Fun times. Let's see. One more. 6 minus the square root of 108 over 18. So, first of all, we're going to do that. 6 minus the square root of over 18. What two numbers multiplied together give me, oh gosh, 108. Let's say 108. 3 goes into 108. 3, 9, 1, 8, 39 times. That doesn't help me a whole lot. So 39 times 3, 54 times 2, 27 times 4. Let's look at that one, see if that'll work. Oh, I got another one. 36 times, what is it, 3. That is a better one because I can take the square root of that, and that's a prime number. So let's do that one. That'll make life easier. Now, any of the other ones would have worked. It's just this one's easier. Square root of 36 is 6, so we pull that out, and that's over 18. Factor a 6 out. Six over 18 is 1/3. I really don't need that, so I end up with 1 minus the square root of 3 over 3, and we'll call that good. Okay, we're going to skip the golden rectangle and the golden ratio and go ahead and give it a shot with the problem sets. I think we've done enough of these that you'll probably be okay. So that's it for 8.2.